Okay, now let's do an example. Trust me, it'll make you feel better. Find the gradient of this vector. Do you guys want to try it on your own? Do you remember what gradient was? It was the del operator operating on a scalar. Is this a scalar that's given? How will we do it? So this vector on R, and it's giving it to us in Cartesian coordinates. What is our del in Cartesian coordinates? Partial over partial x, partial over partial y, partial over partial z. Agreed? And I, j, and k. And I have to add r to it. So that will make this r, r, r. You see the progression? Plug in r, it will become partial over partial x, square root of x squared plus y squared plus z squared I hat, plus partial over partial y, square root of x squared plus y squared plus z squared j hat, plus partial over partial z of x squared plus y squared plus z squared k hat. This will be nothing other than 1 over 2 square root of x squared plus y squared plus z squared times 2x. Is that correct? Plus 1 over 2 of x squared plus y squared plus z squared times 2y. Oh, and then ijk's will come along, right? J. Plus 1 over 2 square root of x squared. Casey, do you understand where we got this from? That means 2's will go away. Am I left with because I'm lazy, I'm not going to do one more step. Xi plus yj plus zk. Is xi plus yj plus zk r? Is that a vector r? And is this the magnitude of r? And I know r can be written as that. So r hat can be written as r. May I rewrite that as the unit vector r? So the slope of the magnitude of a vector just tells you the direction of the vector. Yeah, the first time I realized that, I was like, this is so cool. All it is telling me what direction I need to go to. That is so cool. What's the next thing we did? So we did 3 things, right? One was called gradient. Next one was called
Divergence.
And the last one was
Curve.
Okay, so let's do divergence next. So the question is saying, so we won't do all of them. I'll leave some to you. Suppose that the functions are given as this, and that. Calculate its divergences. So for this one, they give me VA equals x hat plus y hat plus z hat. Everybody understands x hat, y hat, z hat, right? I tend to write ijk, but you could just as well write xyz. It doesn't matter. And then they give me this one as yb equals just this. And they give me this one as vc equals z hat. Casey, you get to pick which one you want to do. And it says calculate their divergences.
Which one's the hardest?
I don't know. You pick one.
Well, that's not helpful, Dr. Zane.
I'm sorry. Do you want to do A, B, or C?
C, because my name starts with it. Go.
Okay, so let's do C. What does a divergence look like? What's the formula for divergence?
The dot product.
It's the dot product. Woohoo! Of the del operator with whatever vector that's given. So that means it's going to be partial over partial x of v plus partial v over partial y plus partial v over partial z. Will it have ijk's? No, because it's a dot product. Very good. So what's the v that's given? Z plus partial z over partial y plus partial z over partial z. What is partial z partial x? 0, right? What's this? 0. And what's that? 1. So the answer to this is del cross v. The divergence of this is 1. That means it actually has a divergence. So look at this picture. Even though when I defined divergence, I defined it like this, but this picture also has a divergence because it's becoming, the vectors themselves are becoming bigger. It's a divergence in magnitude. Whereas if you look at picture B, are they expanding? Is the direction changing? Are the vectors themselves changing? The magnitude. So what do you expect this divergence to be?
0.
Can you prove it? All you have to do is do what? Del cross VB. And you see there's actually no variable. It's just a z. So if you take partial of 1, what will you get? 0. So that function does not diverge. So the divergence could be in magnitude or it could be in direction. Oh, homework, try this one. And for this, what will you have to do? Del cross VA. It's just a dot product, so it's not fancy. I think this one will have a positive divergence, right? Vectors going away, positive divergence. Okay, absolutely last thing. So we did divergence, we did gradient. What was the last thing left? Curl. So the question says, this field is given by minus y x hat plus xy hat, and this is given by xy hat, and they're asking us to find the curls. How would you do that? What's a curl? Cross product. Very good. So pick one. Casey, which one do you want to do? 2? Okay. So this will be I, J, K, partial over partial X, partial over partial Y, partial over partial Z, 0, x0. So then what will be the answer? So I do I hat partial over partial y of 0 minus partial over partial z of x minus j hat partial over partial x of 0 minus partial over partial z of 0 plus k hat partial over partial x of x minus partial 0 over partial y.
Dr. Zane, you lost me. I don't know
Wait,
what-
it's just matrix.
Oh,
Multiplication. Yep. So then this goes to 0. This goes to 0. This goes to 0. This goes to 0. This is 0. And we are only left with this. And so the answer is that this curl has a magnitude 1, and it is in the z direction. It's curling in the z direction. Around the z. So even though this doesn't look like it's curling, Casey, that was a good pick. This one is obvious, right, that it's curling. This one doesn't, it's not obvious. But if you think about it, if you have speeds that are slower on the inside and faster on the outside, eventually what will happen? Do you see it? They will start to curl in. So even though this picture does not look like this should have a curl, it does.